Hello, welcome to our second webinar. Please wait for the others also. This webinar is recorded. Okay, we can start now.
Welcome to the second webinar of Ergodesign, improving digital skills for ergonomics and bioengineering innovation for inclusive healthcare. These programs, the partners of these programs are NTUA, Ombuda University from Budapest, from Hungary, University of Slovakia, Tukey University, Poznan University of Technology from Poland, Technical University of Varna from Bulgaria, and Prospecto from Italy. The general objective of the project is to support the introduction of ergonomic and bioengineering innovation in implantology and prosthetics through new digital application and training in their use. More specifically, it's to increase the students' knowledge in ergonomics and bioengineering and their digital skills for designing and producing 3D printing medical products. To increase in knowledge for designing healthcare implants for people with special needs, to expand the trainer's knowledge of software and digital tools, including their use and adoption for training purposes, to improve students' employability in the medical implant sector, and to create a community of practice focused on ergonomics and bioengineering topics. We all know how important healthcare is and what happens when other values replace the priority of human lives. It is clear that healthcare must be inclusive, allowing everyone to be able to access medical cures. Medical systems should take care of everybody, including people with disabilities and their needs of special assistance. These medical problems solved in whole or are part by the application of ergonomics and bioengineering innovations. For this reason, this project aims to a new curriculum which covers different topics and taking into consideration the requirements of people with special needs to create a more inclusive healthcare system. Furthermore, the introduction of advanced software of 3D printing technology in medical implant sector presents a revolutionary opportunity to innovate and improve patient care. And finally, this project emphasizes the need to equip students and education with essential digital skills. The specific task that we have to follow was to select digital tools that are currently used for design and production of medical implants. The identified digital tools were analyzed, and then we developed dynamic toolkit. Once the dynamic toolkit was developed, we defined the design principle for the course that was the start point for the definition of the Ergodesign curriculum and also for training material. Finally, all the training materials were uploaded on the collaborated platform. The purpose of the training course is to train a new generation of medical and technical staff to be able to boost innovation in the medical implant sector, to answer unsolved social issues related to the requirements of people with special needs. The target groups for this training material, this training course is bioengineering students, medical staff, and technical staff. The starting point for the training course curriculum development was the Delphi study, which allowed to verify the true training needs in a specific area. Based on the results from the Delphi analysis, the course includes the following 6 topics areas: biomaterials and their processing technologies, design, imaging and digital support for medical device design, Internet of Things solutions in medicine, basic medical issues, medical and hospital equipment, soft skills and management, and ergonomics in relation to requirements of people with special needs. The design of the learning process is a 5-step instructional design. Started with the analyze and ended with evaluation. More specifically, the purpose of the first phase is to gain a thorough understanding, to scope the content and delivery methodology, The second phase is to identify and develop strategies for achieving performance outcomes. The third phase involves the creation of online modules, teacher resources, face-to-face classes and student instructions. The next phase, the implementation phase, is to deliver the course, which may include a test run for user accessibility. And finally, the last step is to conduct it after each phase in order to gather our feedback. Four terms are important for the development of the training course. More specifically, we have to know the meaning of learning outcomes, knowledge, skill, and social competence. Learning outcomes are the statements of what a learner knows, understands, and is able to do on completion of a learning process. Knowledge means the body of facts, principles, theories, and practices that is related to a field of work or study. Skills means the ability to apply knowledge and use know-how to complete tasks and solve problems. And finally, social competence means the proven ability to use knowledge, skills, and personal social and methodological abilities in work or study situations and in professional and personal development. The title of the core of the training course that we developed is 3D printing for healthcare, and provides a specialized interdisciplinary education concept of theoretical and practical aspects of additive technologies application in biomedical engineering to enhance human health and well-being. The graduates gain a comprehensive understanding of core engineering principles related to the implants and the prostheses produced by additive technologies. Students will utilize knowledge from the biomaterials and the processing technologies, basic medical issues, digital supports in medicine, medical and hospital instrumentation, ergonomics, as well management of process of the 3D printing for healthcare. To take the level of this course is undergraduate, graduate, postgraduate, and lifelong education, and also it's elective. The duration of this course depends on student because it's an e-learning material, and the assessment of the evaluation of the students carried out through self-assessment tests. To take this course, students should have basic knowledge of mathematics, physics, chemistry, material science, computer graphics, thermomechanics, and hydromechanics. Also, the students should have the necessary skills such as knowing how to construct simple components, to use professional terminology and process technical documentation, to read technical drawings of products or parts and propose the most efficient methods and procedures for their production, to analyze and evaluate technical solutions, to perform basic analysis of machinery and production technologies, to carry out technical supervision at workplaces, to verify new production procedures, collaborate on the implementation of technological changes and innovative activities, to prepare a report on the results of a laboratory experiment, to provide technical preparation for changes and introduce new products, and to determine the method of quality control and technical tests to cooperate on production and quality control. And of course, the students needed to apply the knowledge in a way that shows a professional approach to their work, and they have the competence that are usually demonstrated by creation of defending arguments and solving problems in their professional field. To collect data, to communicate, to share ideas, solve problems, and of course, to have the ability to independent learning and study. So based on the 6 topics areas that we mentioned previously, the content of this training material of this course are the following. First of all, we have the introduction, the benefits of implantology in the healthcare system, management of patient and production process for people with special needs, introduction of the biomaterials and biocompatible materials, processing technologies of biomaterials, yes, and biocompatible materials, 3D printing of metals, ceramics, and polymers, anatomy of the implantology, geometry, sizes, and general and special examples, material selection of implant as a function of the anatomy of the application, human implant compatibility, test methods, and surgery in implantology, database programming, artificial intelligence, telemedicine system, medical informatics, 3D scanning process and device, medical images, application of 3D images for designing as a function of the processing technology, medical equipment, hospital equipment, and finally, the final exercise. When the students complete this course, then they will able to identify the need of use of biomaterials for 3D printing on his own in healthcare, to understand the requirement of biomaterials and biocompatible materials, to understand basic human body function, to understand basic medical issues in healthcare service, to understand the attitude how to address to people with special needs and adopt inclusive setter approach with soft skills and emotions, and to understand basic knowledge for management for inclusive healthcare. Also, the student will be able to select the most appropriate material for real application, to propose an inclusive solution to medical product development, to work with patient data and using digital tools for implantology and prosthetics, to select appropriate technology for implants and prosthetics production, to design implants and prosthetics with free available software, to use medical tools for people with special needs, and to use ergonomics methodology and tools for manufacturing personalized implants. And finally, the graduate will be able to apply the knowledge in a way that shows a professional approach to their work, and they have a competence that are usually demonstrated by the creation of defending arguments and solving problems in this field of study. To collect data, to communicate, to have ideas, to solve problems, to develop the ability for further education necessary for studying with a high degree of independence. The teaching methods that we use to deliver this training course are lecturing, e-learning, individual works of students, works in pairs, teamwork, exercise on computer, and practice exercise. The assessment of the students is carried out through self-assessment in a form of quiz after each topic, and also the final practical exercise. A student must have earned a score above 66% to be considered to have successfully passed the course, and the duration of the course is 14 weeks, and a minimum of 3 ECTS are awarded. All the training materials are uploaded on the collaborated platform. The collaborated platform is a web-based system that provides an online learning environment. This system will offer students and academics to access to a range of digital educational contents. Also, it allows educators to create educational content. This platform is easy to use, allows students to track learning outcomes, to collect notes, and to report learning experience. Students also will have individual accounts with dashboards showing progress at upcoming deadlines. Educators and learners can monitor progress and completion with various tracking options. And from the Ergodesign page, everyone can easily connect to the platform and register for the course of Ergodesign. First, you have to create an account and fill in some personal details. As we can see, all the courses have the same format. First, there is a short description of each module, the basic knowledge that a student must have, also what the student gain after finish this module, and the teaching method and the examination way. Moreover, students can see the contents of each module. Finally, the student can watch the video of each module and download the training material. The last part of the module, as already mentioned, concerns the final project that each student has to do. As an example is the replacement, the hip replacement, where the students has to do various tasks. One of them is to design the implant. There are a lot of digital tools that we can use to design implants, but not all of them have the same capabilities. For this reason, a dynamic toolkit was developed within this project to help users to choose the appropriate software. From the Ergodesign page, everyone can easily use a dynamic toolkit. The main part of the dynamic toolkit consists of parameters which are divided into 4 main categories. And there is also a table with 3D CAD softwares. Users have the option to select the desired parameters, and then the dynamic toolkit recommends the most suitable 3D CAD software. For example, if the user selects Windows Freeform Modeling, Assembly, and Special Price for Student, the dynamic toolkit suggests that the most suitable CAD software are Fusion 360 and Siemens NX. Also, the user can read a short description of each 3D CAD software before he selected the final the software that he wants. So the objective of the dynamic toolkit was to put in order the various digital tools which are available in the fields of ergonomics and bioengineering for designing and producing 3D printing models of medical implants, to systemize them according to a common format, to create a tool that can help the users to select the suitable tool for the right design. And the purpose of the dynamic toolkit is to increase the educational digital skills of health education academics in the field of 3D design and the production of healthcare, to increase the digital skills of students for healthcare application in prosthetics and implantology, and finally to increase the knowledge of project topics to learn how to deal with patients with special needs. And now the rest part of this presentation. See you maybe with the presentation.
Hello again. After we finished all the above tasks that Maria explained, we created the handbook that summarized the knowledge and experience that we gained during the project into some guidelines for effective replication of similar courses. This handbook can also be applied in classic professional areas when educational content is stable, or where there is a need to innovate the content into new conditions. This guide includes all the experience that we gained when we created this training course on an electronic platform. We tried to be more ecological, and that is the reason that we have this handbook on screen and not on paper. All the topics of the Ergodesign course have a very simple structure. First, we have the topic description, then the topic content information, the topic prerequisites, the learning objectives, the teaching methods, And finally, there is the assessment and evaluation part. The course structure is the following. The first chapter has to do with the benefits of implantology in the healthcare system. Then there is a chapter with an introduction to the biomaterials and biocompatible materials. The third chapter is about processing technologies of the biomaterials and biocompatible materials. And then we have a chapter for 3D printing of metals, ceramics, and polymers. Then there is the anatomy of implantology, the geometry and sizes, the material selection for implants as a function of the anatomy of the application, the human implant compatibility test methods. Then we have the databases, programming and artificial intelligence, the telemedicine system, the medical informatics, 3D scanning processes and devising, then the medical imaging, the application of 3D images for designing, and last, we have the medical equipment and hospital equipment. After all these chapters, there is a test and some exercises that students must do to finish the course. And we created the contents of the handbook in a way that will be helpful and easy for everyone to understand. At first, we have some abbreviations and a small introduction. And the first chapter is generally about the project parts of Ergodesign. We have the course basics and the course topics. The second chapter is the organizational tasks. There we give some tips for digital-based course design essentials. It has some chapters about the audience research, the course topic, the course outline, the lesson structuring, and finally the course design. After that, we have the third chapter, where we give some guidelines and tools for monitoring and evaluation. There is assessment versus evaluation, and also basic metrics for monitoring learner performance, progress, satisfaction, approval, competency in online courses. The last chapter has to do with European credit transfer system recognition process, where we have some information about the ECTS system. And finally, we have a chapter with the conclusions and the references. Ergodesign project intention was to prepare a digital-based course in the required quality level. And also, we would like to share a course replicating best practicing and some organizational task tips. In other words, to define generally applicable principles that can be used for the presentation of similar courses. The best practice for organizing and executing innovative online training courses is to conduct an informative overview of the educational offering in order to provide an efficient definition to online training that meets the needs of the market and also provides insight to a given area of expertise. The course of design structure has 5 clear steps. First, there is the audience research, the course topic designation, the course outlining, the structure, the lesson structuring, and finally the course design. At first, we have to produce a course for the real market needs. So it is very important to define the audience. After that, we should create a persona of the ideal student that will attend this course. After the definition of the perfect, the ideal student, based on this persona, we define the topic of the course. For the course outline, we should answer some questions. such as who is offering this course, why someone would take this course, what will they learn, how we're going to offer the educational experience, also when this course will take place, and finally, how much does this course cost, because when they choose between some courses, it's very important to know also the cost of them. And then we have a lesson structuring, a general idea of how the lesson will be. And finally, a more detailed course design, where we prepare a solid plan for the online training content. Some guidelines and tools for monitoring and evaluation. We should consider at first that learners are always looking for the best outcome of their investment. And when we say investment, we mean the time and the money they invest for a course. So metrics are very important for building a course by permanently improving the courses, taking into consideration the learner's feedback. So choosing the right course metrics will help to determine what learners think of the course and offer the designer the chance to improve the course all the time. The assessment diagnoses learning gaps and progress. So it is important to have clearly defined evaluation criteria, to have regular feedback, and so also continuous assessment and improvement of the assessment procedures, not only improving the course, but also the procedures of assessment. When we talked about evaluation, we mean to always ask if what we created is good enough, and if not, why it isn't so good, how can we improve it, what the learners think about it, and take into consideration all this. Some metrics for online course monitoring is the learner performance and progress, the learner satisfaction and approval, and also the learner competency and proficiency. Some words about the European Credit Transfer System recognition process, the ECTS. The European Credit Transfer and Accumulation System is a standard means for comparing academic credits. It is a student-centered learning for credit accumulation and transfer, which is based on the principle of transparency of the learning, teaching, and assessment processes. ECTS objective is to facilitate the planning, delivery, and evaluation of study programs and student mobility by recognizing learning achievements, qualification, and periods of learning. When we say that is a student-centered learning program, we mean that there is a reliance on the active rather than passive learning, that it is given emphasis on the criteria, critical and analytical learning and understanding. There is increased responsibility and accountability on the part of the student. And finally, there is increased autonomy of the student. ECTS can be practically applied for program design, delivery, and monitoring, such as this program that we creating, the design. Also can be used for mobility and credit recognition. For example, when students travel abroad with Erasmus project, they have a standard method of having the points from each lesson they participate. Also lifelong learning, because these courses can be chosen not only by students, but by everyone who needs to learn something new. Also for quality assurance and in support documents like course catalogs and documents for credit mobility. As we finish this project, We hope that we offer some results, very important. We hope that we increase the pedagogical skills on higher education lecturers in the fields of 3D design and production of healthcare implants. Also, we hope that we increase the number of higher education lecturers that will take into consideration the requirements of people with special needs when they deliver their training. That we increase the higher education students' digital skills and also higher education students' employability in the healthcare sector. Also, we promoted the exchange of good practices, open discussion among higher education lecturer, academics, and students, and also other stakeholders in the fields of ergonomic and bioengineering. Finally, we hope that we promoted the topics of the project and training other higher education lecturers on how to replicate courses like Ergodesign. In the future, we hope to also have a very positive feedback, that we strengthen and exchange the knowledge between the partners. We also hope that we will have future cooperation beyond this partnership in new projects like this. Also, this program will help to improve the quality of technical education and e-learning in the future. And the initiative aims to deliver a student-centered e-learning course that combines theory and practical exercises in order to enhance digital skills and employability, addressing the demands for skilled professionals in the industry. Finally, we know that there is a pressing need for everyone, including those with disabilities, to easily access medical care, especially during emergency, but also in preventative medicine. And we hope that this program helps to this point. That was all for the presentations. We are open to questions or to some comments and ideas you may have to improve the project. So you can ask whatever you want. Let's take some time if anyone has a question. Okay, there are no questions. So thank you for your attention. Okay. We hope that it was interesting presentation and you liked